This is Lab 7, Circular Motion and the Conical Pendulum. This handout will be slightly different than yours, I believe, but it has essentially the same information. So for the first part, I'm going to draw the picture. So you can see the L is the length of the string, of course, and I think that you measured it actually to the center of the mass. And H is the height above the bottom that you dropped it from. Doesn't really matter what H is as long as you drop it from the same spot consistently. So you measured the mass of the pendulum bob by letting it hang, and a typical value would be 1.1 newtons for the force of gravity, and then you divide it by 9.8 to find the mass. So that gives you the mass, and the uncertainty on the mass will be the same percent uncertainty on Fg will be the same, will be the percent uncertainty on M. So the question is, what is your uncertainty on Fg? Ideally, you would look at the force meter, and when you measured the mass, it should have looked something like this, where there was some ripple, but it settled out to a number below 0. And this is around negative 1.1 newtons because of the direction. That's why it's negative. So your uncertainty would be the size of this ripple. So say it's going between 1.0 and 1.2, then your uncertainty would be plus or minus 0.1 newtons. Now, if you didn't look at that ripple, then you'll have to estimate your uncertainty, and I would say 0.1 newtons is a pretty good estimate. So then you convert that to percent to get the percent uncertainty on mass.